Welcome back. In this last part, we'll be doing a little bit of equation solving and also talking a little bit more about composing trig functions with their inverses. First, solving inverse trigonometric equations. Not too bad to do, and in fact, some of the ideas behind it are similar to what we did when we were solving logarithmic equations or exponential equations. So first, as we would have, isolate that special function, in this case the inverse trig function. And after you've done that, think about the output of that inverse trig function, because you might in some cases be able to stop there. So for example, if you had isolated an inverse trig function sine inverse of x, and it was turned out to be that sine inverse of x needed to be equal to pi, well, you know that sine inverse only has outputs between negative pi over 2 and pi over 2, so there should be no solution to this. And so then you could stop right there. Now, if on the other hand it was somewhere in that output, that range for sine inverse, so let's say it was sine inverse of x is equal to pi over 7, well, what would you do in that case? Well, just as we did using the inverse to rewrite an equation, so for an exponential equation, we used its inverse, the logarithm, to rewrite it, or for logarithmic equations, we used its inverse, the exponential functions, to rewrite it. So here, if it's an inverse trig equation, we'll rewrite it using trig functions. So for example, if you had sine inverse of x being pi over 7, then you could rewrite it as the trig equation, sine of pi over 7 is equal to x. Now, if you can evaluate your trig function exactly, go for it. That's sort of the ideal, and if you can't, well, then you'll have to give an approximate value. But again, only giving approximate values if I ask for them. If I ask for an exact value, that means that an exact value would be possible. Now, the other thing that you could have, you might have something more complicated than just sine inverse of x. You could have something like, for example, sine inverse of 3x. But you can simplify your life by doing a little substitution. First, replacing 3x with u, solving for u, and then once you've found what u is, go back and use that to solve for x. So for this first one, we're looking to find the exact solution to 18 arctan x minus 6 pi equals 0. So the first thing that I'll do is I'm going to take my tangent inverse function and I'm going to isolate it. So first, I'm going to bring that 6 pi to the other side. And here I'm going to rewrite this as tangent inverse. Arctan of x is the same thing as tangent inverse. Divide both sides by 18. I'd have 6 pi over 18, which is the same thing as pi over 3. And now we're pretty much good to go, because we know that pi over 3 is in the output. It is in the range of tangent inverse. So we can rewrite this and say that this will be written as a tangent function now, switching the inputs and the outputs. So now pi over 3 would be the input and x would be the output. And so the only thing that we would need to do now is figure out what x is, and for that we would need to evaluate what is tangent of pi over 3. And that's something where we have a special triangle to do that for us. That's our 30, 60, 90 triangle. And for tangent of pi over 3, that would be opposite over adjacent, or root 3 over 1, which is just root 3. So my solution for this equation is just root 3. Let's do another one here. One thing I'm going to do just to make my life a little bit easier, I'm going to first start off with a little substitution. Notice I've got sine inverse of 2x. I'd like it to just be something like sine inverse of u. So that's what I'll do. I'm going to replace the 2x with u. So I would have pi minus 3 sine inverse of u equals to 2 pi. And now I'll bring the pi to the other side. So that would give me pi. Divide by the negative 3, that's sine inverse of u is negative pi over 3. And we stop and ask ourselves, is this number something in the output, in the range of sine inverse? Sine inverse has output between negative pi over 2 and positive pi over 2, and yep, that's in that interval, so good for us. We do have a solution here. We can say then that rewriting this as a trig function, sine of pi over 3 negative would be u. And now for that, we can do one little bit of extra work here. You can do, for sine of negative pi over 3, you can start off by taking sine of negative pi over 3 and drawing the angle and thinking about whether sine is positive or negative in that quadrant, and all the usual shenanigans that we've done in the past. Or if you're thinking cleverly, you can use the fact that you know that sine is an odd function. So sine of negative pi over 3 is negative of sine of pi over 3. And I know what sine of pi over 3 is. Going back to my special triangle, sine of pi over 3 would be opposite over hypotenuse, which would be root 3 over 2. So that means that u then is negative of root 3 over 2. Now, of course, we're not finished yet because we still need to figure out what x is. This is the next part of our problem, which is what is x? We know that u is the same thing as 2x. So that means x itself should be negative root 3 over 4. And so there we go. That's my solution to this equation. One more for fun. We have negative 4 cos inverse of 7 pi. So I'll isolate that inverse cos function. And then here's where I'm going to pause for a second. Oh, I dropped my negative. There we go, that's better. And here's where I'm going to pause for a second. Because if you're remembering what I did for the previous two examples, at this stage I said we should stop and think about, is the output of sine inverse, could it be negative pi over 3? Or over here I said, could the output of tangent inverse be pi over 3? So we should be doing the same thing here and thinking, well, could the output of cos inverse be negative 7 pi over 4? And right away, the answer should be no, of course, because we know that when we're thinking about cosine inverse has a range from 0 to pi. Remember that cosine inverse would have its domain being the numbers from negative 1 to 1, and the range would be the same thing as the restricted domain for cosine from 0 to pi. And so at this point, we can stop and we can say there's no solutions. And this is the important thing here. We have to be kind of clever, because if you didn't do this, you could send yourself down the wrong path and come up with what looks like an answer, but is actually incorrect. And by that I mean, let's pretend that we didn't notice any of this. let's pretend that we just decided to move along and say, okay, well, I'll rewrite this as my trig function, switching the inputs and the outputs. You'd get something that you could evaluate. I mean, you certainly could calculate out what is cosine of negative 7 pi over 4. That is something that does have a value, and you would think that that would be the solution for x. Unfortunately, this is the problem, that although this equation does have a value for x to it, this equation does not. Just kind of in the same way how log of negative 2 and log of negative 3, they're both individually undefined, but if you were to combine them together to make log of 6, now it's something that's defined. It's that same sort of problem that we had when we were solving our logarithmic equations, where it wasn't the simplified version that we had to worry about, it was the original version. Does that have solutions? So although this line here in red, there is an answer for what is x, for the original equation, there is no value for x. And that's because, again, for cosine inverse of x, the output, the range, is from 0 to pi. So because negative 7 pi over 4 is not in the range of cosine inverse, so there is no solution. I mean, the other way that you would be able to confirm this, let's pretend that you'd actually gone down that wrong path and you'd calculated out what is cosine of negative 7 pi over 4, and you thought that that was your value for x. If you used your calculator, you'd find that cosine of if you used your special triangles rather, you'd find that your value for cosine of negative 7 pi over 4 turns out to be root 2 over 2. And if you tried to check your solutions by putting in root 2 over 2 for x, you'd find cos inverse of root 2 over 2 is not 7 pi over 4, negative or positive. It's actually pi over 4. Remember, again, it's the output for cosine inverse that's the restriction here. It can only be between 0 and pi, and so if you have an output that's supposed to be outside of that range, then that means that there's no solution. So for this problem, no solution for x. Let's do one more here. Again, I'm going to do a little bit of a substitution. I want to not deal with that x minus 3 over 2, so I'm just going to replace that with u. And so now I've got 6 sine inverse of u minus pi equals 0. So I've got sine inverse of u is equal to pi over 6. And pi over 6 definitely is in that output of sine inverse. Sine inverse's range was from negative pi over 2 to positive pi over 2. Pi over 6 is in that range. So we can rewrite this and say, well, that means sine of pi over 6 is equal to u. And if we drew our special triangle, the 30, 60, 90 triangle, make that look a little bit nicer. So sine of pi over 6 of 30 degrees would be opposite over hypotenuse, or a half. So u should be equal to a half. And then we just need to now go back and find out what is x. So u, which is equal to a half, is the same thing as x minus 3 over 2. So now I just need to solve for x, multiplying both sides by 2, and then solving for x, and I find that x is 4. All right, so we're also going to do a little bit of composing trig functions and inverse trig functions, this time mixed. So before it was sine and sine inverse, or cos and cos inverse together. Here we'll be looking at things like sine with tangent inverse, or sine inverse with cosine, things like that. And there's two cases. There's the case where the inverse trig function is on the inside, so something like sine of tangent inverse. And then we'll have the case where the inverse trig function is on the outside, so something like tangent inverse of sine. So the idea here is that if you're thinking about something like this, what is sine of cosine inverse of 5/7? You know that whatever cosine inverse of 5/7 is, it's going to be some sort of an angle. So that's what we start with. We say, well, let's replace cosine inverse of 5/7 with our angle theta. And if this is something where you can solve right away, then go for it. Unfortunately, we wouldn't be able to here because we'd be looking for the angle theta where cos of theta is 5/7, and I don't know what the angle theta might happen to be in that case. But that's not a problem because, of course, we also know that if we're thinking about cosine of theta being 5/7, you could think of an angle being drawn that passes through the point, an x and y point, where the x coordinate is 5 and where r is 7. Remember that we had that definition of cosine of theta being x over r. So we know that whatever our angle theta is, it passes through some point 5y. We don't know what y is, but where r, the distance from the origin to that point, is 7. Once we've got this ready to go, we can find out what y needs to be. So once we've done our little bit of work here using the fact that r squared is x squared plus y squared, you can solve and find out what y is. Y is 2 root 6. And then at that point, you'd be looking at evaluating what is sine of theta. And for sine of theta, well, now you know what y is, now you know what r is, now you can find out what sine of theta is. So something like this. So we're looking for cosine of sine inverse of negative root 2 over 2. And for this, I would say, well, number one, first, let's let theta be sine inverse of negative root 2 over 2. So that means that sine of theta is negative root 2 over 2. And we could figure that out. We could figure out which angle is it that gives us sine a value of negative root 2 over 2. You might find out, or either using special triangles or otherwise, you might know that sine of 45 degrees is positive root 2 over 2. And so sine of negative 45, sine of negative pi over 4, is negative root 2 over 2. So once we know what theta needs to be, in other words, theta is negative pi over 4, now we just need to evaluate what is cosine of negative pi over 4. And this is an easy enough one for me to do. I'm going to use my special triangles here and the fact that cosine is an even function. So cosine of negative pi over 4 is the same thing as cosine of positive pi over 4. That's because cosine is even. And cosine of positive pi over 4 would be, using my special triangle, adjacent over hypotenuse 1 over root 2, which simplifies to give me root 2 over 2. Next one, we've got cosine inverse of negative 6/13 as what's on the inside. So I'll let u be cos inverse of negative 6/13, or rather theta. That means cos of theta is negative 6/13. So number one, again, we're thinking about cosine inverse, and cosine inverse only gives us angles in quadrants 1 and 2. So that means that whatever angle we're thinking about has to be in quadrant 1 or 2. Now, for cosine to be negative, that would be then quadrant 2. So this is where I'm going to draw my angle. We have to, again, still know what is the restricted domains and ranges for these functions, so that when I draw things, I'm thinking correctly about whether x is positive or negative and whether y is positive or negative. So here, the value for x then should be negative 6. R is 13, and the value for y is unknown. And so all we have to do is find out what is y. We know that x squared plus y squared is equal to r squared. In this case, x squared is negative 6 squared, or 36. R squared is 169. That's 13 squared. And so we have that y squared would be 133, and so y would be root of 133. This is the reason why we drew the diagram, by the way, because at this point you might be asking yourself, is it plus or minus when it comes to the square root? And because we know that our quadrant that we're in is quadrant 2, where the y coordinate is positive, then we know that the y value must be positive root of 133. And then we could try to write this in simplest terms after this, but actually root of 133 is as simplified as it's going to get. So the only thing left to do now is to evaluate, so what is tangent of cosine inverse of negative 6 pi over 3, or in other words, what is tangent of theta? And we know that for tangent of theta, that would be y over x. The y value is root of 133, and x was negative 6. So tangent would have a value of negative root 133 over 6. One more to do, secant of tangent inverse of 1. So first off, let's find out what is tangent inverse of 1. So for this, we'll need to remind ourselves, we know that we'd be looking for tangent of theta to be equal to 1, and we know that tangent of pi over 4 is equal to 1, and that's, of course, using our special triangle. For the 45, 45, 90, tangent of pi over 4 would be 1 over 1, which is just 1. So the angle that we're talking about really then should be pi over 4. So we're really looking here at now secant of pi over 4. And of course, secant of pi over 4, we know what that is. That's the reciprocal of cosine of pi over 4. Cosine of pi over 4 would be adjacent over hypotenuse, 1 over root 2. So secant should be the reciprocal, hypotenuse over adjacent, root 2 over 1. Now, if we're doing with the reverse here, the inverse trig function is on the outside, then again, we might have to do things exactly or do things approximately. So exactly would be if we're looking at something like, well, what is sine inverse of cosine of 0? you could figure out what cosine of 0 is. That's just 1. So you'd be looking for sine inverse of 1. And so you'd be asking yourself, which angle theta is it that is sine inverse of 1, or sine of what angle gives you 1? And we know that in our little restricted domain, that would be pi over 2. So that means that my answer would be pi over 2 for this question. Now, if we have an angle here that we can't evaluate directly, then you could, of course, always use your trig functions, just making sure that they're in radians mode. So here we're going to find the value of these compositions of functions, and we'll give the exact value if we can, and if we can't give the exact value, then we will give an approximate value using our calculator. So for the first one, I'll first need to figure out what is sine of 7 pi over 4. And so if you were to draw your angle, 7 pi over 4 happens to be in quadrant 4, where sine is negative, and you also know it has a reference angle of pi over 4. So if you used your special triangles, sine of pi over 4, you'd find that that's root 2 over 2. And so sine of negative pi over 4, which is the same thing as sine of 7 pi over 4, would be negative root 2 over 2. So here, when we're looking at what's on the inside, cos inverse of sine of 7 pi over 4, it's really what is cos inverse of negative root 2 over 2. So we'd have to ask ourselves, which angle is it that gives us a value for cosine that is negative root 2 over 2? Remember that cosine inverse is only going to give you outputs in quadrants 1 or 2. It's not quadrant 1 because that's where cosine would be positive along with everybody else. It would have to be in quadrant 2. So we're going to get an angle that's in quadrant 2 then. And now if you're thinking about this, you know that cosine of pi over 4 is root 2 over 2. And so you can find that if you were in quadrant 2, and had a reference angle of pi over 4. In other words, if you were talking about cosine of 3 pi over 4, cosine of 3 pi over 4 would be negative root 2 over 2. So cos inverse of negative root 2 over 2, that would be 3 pi over 4. All right, one last one to go here. We've got tangent inverse of secant of pi over 7. And so we want to ask ourselves, can we come up with the exact value for this, or do we need to come up with an approximate value? And so for this one, if you wanted to evaluate it directly, you run into a problem right away, because secant of pi over 7, I mean, that's not really a nice value that we can find right away. But this is something where we could use our calculators. So the first thing that I might do is find out what is secant of pi over 7, and then evaluate what is tangent inverse of that. So using my calculator, again, making sure that your calculator is in radians mode, secant of pi over 7 would be found by taking 1 divided by cosine of pi over 7. And of course, remember that your calculator needs to be in radians mode. So when you're using your calculator, it has to be in radians. And so for secant of pi over 7, that would be 1 divided by cosine of pi over 7. And I come up with a value of about 1.109916, something like that. So tangent inverse of secant of pi over 7, that would be tangent inverse, so second function tangent of 1.109916, and I get as my answer about 0.837446, so 0.837 approximately.